Did you know that precious stones are ignored every single day by ordinary people? That's right. Thousands of them go unnoticed simply because they look worthless. Gray, dull, unremarkable. But it's inside these ugly stones that some of Earth's greatest treasures are hidden. Look at this piece of jade on your screen right now. Before being cut, it was just a lifeless rock lying in a riverbed. Only after being split open did it reveal that translucent green, a color that can be worth more than a car. And it's not an isolated case. Opals with intense play of color, those that seem to hold fire and rainbows inside, also hide within lifeless rocks covered by brown crusts and cracks. Most people would probably kick one of these stones aside without a second thought. But those who know what they're looking at understand something simple. Sometimes the outside completely hides the truth inside. Now imagine what would happen if you learned to recognize the signs, the texture, density, subtle sheen, or tiny color spots that reveal when an ordinary-looking rock could be hiding a valuable gem. That's exactly what we're going to uncover today. So pay close attention, because what looks like a simple piece of stone might actually be worth far more than your rent. You'd probably throw this stone away, but inside, it's worth more than your rent. So you should never judge a stone by its look, because what's inside could change your life. In this video, you'll discover how to identify jade and opal in nature, and understand why the world's most valuable gems are often born inside the stones that everyone ignores. The first thing every gem hunter needs to understand is simple, yet it changes everything. The outer appearance of a rock almost never reveals what's inside, and there's a solid scientific reason for that. Rocks exposed to the surface go through a continuous process called weathering. Over time, wind, rain, temperature changes, and chemical reactions with air and water alter the outer layer of the stone. Iron, for instance, oxidizes and forms brown or reddish stains that cover the natural luster of minerals. Groundwater seeps through cracks, depositing clay and silica that create dull, rough crusts. In other words, Earth disguises its own treasures. That geological disguise is what makes a piece of raw jade look like an unremarkable green-gray stone. It's also why a rock containing precious opal can look like nothing more than a cracked block of sandstone. On the outside, it's plain and lifeless. On the inside, it's pure natural artistry. One of the most fascinating examples is fire opal, one of the most vibrant gems on the planet. It forms in volcanic rocks, usually inside basalt or rhyolite cavities, where silica-rich water slowly seeps in, filling voids and fractures left behind by ancient lava. As that silica settles, layer by layer, microscopic spheres begin to organize. When they reach the perfect size and arrangement, they create the famous play of color, the rainbow-like flashes that seem to dance inside the stone. But before being cut or polished, a natural fire opal can look disappointing at first glance. It's often covered with a brownish or gray crust, full of cracks and irregular texture. Only after it's opened does it reveal its internal spectrum of colors. That's exactly why so many are overlooked. The beauty hides beneath oxidation and volcanic dust that took millions of years to form. The same thing happens with jade, especially the variety known as nephrite, found in metamorphic regions rich in serpentinite. These rocks look so ordinary they could be mistaken for any other river or quarry stone. The exterior is smooth, dark green, sometimes with white or yellowish spots. But inside, within compact and translucent veins, lies high-quality jade, the kind used for centuries in carvings and jewelry that today are worth small fortunes. The serpentinites that host jade are formed when ultramafic rocks, made mainly of olivine and pyroxene, are altered by hot, silica-rich fluids. This process creates the perfect environment for jade to grow, but the result is a rock that, on the outside, looks like a plain greenish-black block covered with dull patches. That's why so many deposits go unnoticed until they're cut or split open in just the right spot. In terms of rarity, finding one of these gems is difficult but far from impossible. To put it in perspective, Your odds of finding a natural fire opal in an area known for volcanic activity, like parts of Nevada, Oregon, or Mexico, are much higher than winning the lottery, especially if you know what to look for. Nature leaves clues everywhere. Fragments with glassy shine, lightweight stones with colorful fractures, or simple pieces of basalt with cavities filled with translucent material. And when it comes to jade, places like Wyoming, California, and Alaska still hold underexplored areas where serpentinite and green schist outcrops reach the surface. Most people walking past these stones see nothing but ordinary rocks. But for those who understand mineralogy, each block could be hiding a rare opportunity. Among all the stones hidden within the earth, few are as discreet on the outside and as valuable on the inside as jade. At first glance, it looks like an ordinary rock, greenish-gray, dull, cold, and heavy. But a single cut in the right spot reveals something entirely different, a translucent, dense gemstone with a smooth texture and a deep inner glow that seems to radiate light from within. That's why jade has been considered one of the most noble gems on the planet for centuries. In many Eastern cultures, it symbolizes purity and balance, often valued above gold itself. And that's no exaggeration. A translucent, fracture-free block of jadeite can reach prices of thousands of dollars per pound. What most people don't realize is that jade doesn't refer to a single mineral. In fact, there are two distinct types that share the same name, nephrite and jadeite. They look similar but form in completely different geological environments. Nephrite is the more common type and appears in regions made of metamorphic rocks, where ancient minerals have been transformed by pressure and heat over millions of years. It typically develops within serpentinite, compact green rocks formed by the alteration of magnesium-rich minerals such as olivine and pyroxene. When these minerals react with hot fluids from the Earth's crust, the process slowly transforms them, creating a smooth, oily, and extremely tough texture. Within these blocks, nephrite crystallizes along small fractures and veins, ranging in color from mossy green to pale green, sometimes with milky or whitish zones that give the stone a slightly marbled appearance. Jadeite, on the other hand, forms under completely different conditions. It is created in subduction zones, places where one tectonic plate is pushed beneath another under extreme pressure and temperature. This environment forces aluminum and sodium to rearrange into a new crystalline structure, producing a gem that is denser, harder, and more glassy than nephrite. The most valuable samples display the legendary imperial green color, a pure, vivid, and luminous green. When natural and untreated, this type of jadeite can sell for over $10,000 per pound, making it one of the most sought-after gemstones among collectors and lapidaries worldwide. What makes jade truly fascinating, however, isn't just its chemistry, it's how it feels. Even in raw form, the surface of jade has a distinctive oily texture, almost slippery, as if the stone had been naturally polished. Its weight is another giveaway. Jade is much denser than an ordinary rock of the same size, a clue that experienced gem hunters quickly learn to recognize. As for its color, it can also be deceptive. Natural jade rarely shows a perfectly uniform green. Instead, it displays small tonal variations, lighter streaks, whitish bands, or even yellowish shadows, all typical signs of its natural formation. When searching for jade, it's essential to pay attention to the surrounding environment. The presence of serpentinite is always a strong indicator, but other associated minerals can also serve as important clues. Actinolite, for example, has a dark green color and forms compact fibrous clusters that look like petrified strands of hair. Epidote ranges from pistachio to olive green, showing a glassy or resinous luster. Garnet, especially the almandine variety, appears in deep red to brownish tones and is often found in metamorphic zones, the same environments where nephrite develops. Magnetite, a black metallic mineral that's strongly magnetic, is another useful sign, indicating iron-rich environments favorable to jade formation. These mineral combinations are like nature's signature. When you come across serpentinite streaked with dark and light greens, epidote veins glinting under sunlight, and small garnet crystals embedded in the same outcrop, chances are you're standing in a jade-bearing zone. And if that rock also feels oily, is unusually heavy, and shows irregular green tones, it's time to take a closer look, because the beauty might be hiding just beneath the surface. In the United States, several regions meet these exact conditions. In Wyoming, the Wind River Mountains have yielded nephrite blocks since the 19th century, and they still wash up along riverbanks after heavy rains. In California, particularly in Monterey County, jade can be found between coastal serpentinite rocks, often visible during low tide. In Washington state, the mountainous areas near Snoqualmie Pass contain both nephrite and jadeite, sometimes mistaken for common schist. And in Alaska, especially in the Kobuk region and around Jade Mountain, the jades are exceptionally pure, mined for centuries by native peoples who recognized their value long before modern mineral exploration began. Besides jade, opal is another highly valuable gemstone that can be found under similar conditions. Unattractive rocks on the outside, but with incredible colors within. In photos, it amazes with its multicolored brilliance. But in the field, before being cut and polished, most opals are just pale, dull fragments of stone. What many people call an ugly rock is, in fact, the result of a complex geological process in which water and time work together to create one of the most fascinating optical structures in mineralogy. The formation of opal begins when silica-rich groundwater, the same element that forms quartz and glass, penetrates cavities and fractures within volcanic rocks or sandstones. These waters carry microscopic particles of dissolved silicon dioxide, and as the moisture slowly evaporates, the material is deposited in layers. It's an extremely slow process. Each deposit forms drop by drop over thousands or even millions of years. Over time, the silica particles organize themselves into spherical structures, only a few hundredths of a millimeter in diameter. The size and arrangement of these spheres determine whether an opal will be common or precious. When the spheres are randomly arranged, the result is an opaque, non-reflective stone known as common opal. It may appear whitish, grayish, or slightly yellow, and while it doesn't hold significant gemological value, it's scientifically important because it represents the base structure from which all other opals form. However, when these microscopic spheres align in a precise and orderly pattern, something extraordinary happens. The light that strikes the surface is diffracted, divided into different wavelengths, producing what is known as the play of color, the distinctive color-shifting effect of precious opal. The specific colors visible depend directly on the size and spacing of the spheres. Smaller spheres reflect blue and violet hues, while larger ones produce reds and oranges. It's pure physics applied to geology, no mystery involved. Just a natural structure so precise it behaves like a microscopic prism. Precious opal is therefore the result of an almost perfect natural organization. Its colors do not come from pigments, but from its internal structure interacting with light. That's why every opal is unique. No two will ever display the same color pattern or intensity. In contrast, there is also fire opal, a special variety formed in volcanic rocks rich in iron, especially basalts and rhyolites. In this case, the color is not produced by diffraction, but by the stone's own body color, vibrant shades of orange, red, and gold caused by metallic oxides. Unlike precious opal, whose colors come from light interference, the visual effect in fire opal is due to the chemical composition itself. From a geological standpoint, opal is a low-hardness mineral ranging between 5 and 5.5 on the Mohs scale, making it softer than quartz. It also contains a variable percentage of water in its structure, which explains its sensitivity to temperature and humidity changes. In the field, this means that many opals can lose their shine or even develop tiny cracks if exposed to direct sunlight for long periods. Experienced prospectors know that the best time to observe the true color of a raw opal is under diffused light, shortly after moistening its surface. The most common host rocks are basalts, rhyolites, and some types of porous sandstone. In volcanic regions, it's common for opal to fill ancient gas cavities known as vesicles, formed during the cooling of lava. When these voids are filled with silica, They form rounded nodules or irregular masses, sometimes with a dark outer crust and a translucent interior. This is why so many precious opals remain hidden inside ordinary-looking rocks. It just takes the right cut to reveal the internal brilliance. In the United States, several regions are known for remarkable occurrences. The state of Nevada is one of the most famous, particularly the Virgin Valley area, where precious opals formed within volcanic ash layers. They range from milky to transparent specimens with intense color play and often preserve fossilized wood, adding scientific value. In Oregon, the so-called sunset opals are known for their golden and orange reflections, typically found in ancient basalts. In Idaho, white and fire opals appear within rhyolite cavities, often near ancient lava flows, showing that heat and silica are the key ingredients in this natural process. Economically, the value of opal depends on objective factors: the intensity and variety of colors, transparency, structural integrity, and contrast between the body color and internal light play. Opals with strong play of color, especially those that show multicolor flashes from different angles, can reach high prices even in raw form. In contrast, opaque or cracked samples, or those without proper internal alignment, are less valuable, though still sought after for educational and geological collections. But what is the real market value of these gems, and where could you sell them if you ever found one? When we talk about jade and opal, we're talking about two gemstones that, although they may look simple, move hundreds of millions of dollars every year in the global market. Understanding their value, however, depends on a few key factors: type, quality, transparency, color, and origin. Let's start with jade. It comes in two types: nephrite, the more common variety, and jadeite, which is rarer and far more valuable. Nephrite, found in places like Wyoming, California, and Alaska, is dense, durable, and perfect for carvings and simple jewelry. In the U.S. market, a piece of raw nephrite can sell for $5 to $50 per pound, depending on its color and purity. Once cut or carved, that value can rise to $100 to $300 per pound, especially if the material is translucent and shows a consistent green tone. But when it comes to jadeite, everything changes. This is the most coveted type, particularly the so-called imperial green, known for its intense color and glassy translucence. This material fuels the luxury market in Hong Kong and Myanmar, where jadeite auctions can reach astonishing figures. High-quality rough jadeite can easily sell for around $1,000 per pound, while translucent blocks used for fine jewelry can exceed $10,000 per pound. Once cut and polished, a pure jadeite bracelet or necklace can reach prices of $100,000 or more, depending on the clarity and craftsmanship. The global jade trade is estimated to move over $8 billion annually, with about 70% of that value concentrated in Asia. The U.S. plays a smaller role in this industry, but there are still collectors and lapidaries willing to pay high prices for raw jade with exceptional color and texture. Now let's talk about opal. The principle is the same. Not every opal has the same value. Most of the opals found in nature are common opals, opaque and non-reflective, used mainly for collections or decorative pieces. These usually sell for $1 to $10 per pound in raw form. Precious opals, however, those with the famous play of color, belong to a completely different category. A small raw stone with good color and no fractures can sell for $50 to $500 per carat, meaning that even a few grams can be worth over $1,000. Fire opals, known for their reddish and orange tones, are also highly prized. A polished fire opal of average quality can sell for $200 to $600 per carat, while high-end stones with strong brightness and clear body color can reach $2,000 per carat in specialized jewelry stores. In the United States, the opal trade moves roughly $100 million per year, with Nevada, Oregon, and Idaho as the main sources. Opals from these regions are typically sold at mineral shows, artisan jewelry shops, and specialized online marketplaces. Collectors often buy rough stones directly from small miners, paying much less than the final retail price after cutting and polishing. The difference between raw and polished value is enormous. A dull-looking opal sold for $50 in its natural state can reach $500 or even $1,000 once cut and polished correctly. That's because cutting reveals the internal color pattern, the main feature that defines its value. The same happens with jade. A rough, opaque block that seems worthless can become worth many times more once carved into a smooth, translucent, flawless piece. For beginners, the most important thing to understand is how this market actually works. These stones are not sold in regular stores. The gem trade happens at mineral fairs, auctions, lapidary workshops, and specialized platforms that connect miners directly with collectors. There are also intermediaries who buy rough stones, send them for testing and cutting, and then resell them to jewelers. It's a niche market that requires technical knowledge and professional connections. What truly makes these gems valuable is the combination of geological rarity and aesthetic appeal. Jadeite represents the perfection of mineral transformation under extreme pressure. Opal, on the other hand, is a physical record of silica's natural organization, something no human technology has ever replicated with the same quality. Both are examples of how nature turns simple elements, magnesium, iron, aluminum, and silica, into stones that shine in the windows of the world's most prestigious jewelry houses. So if this is your first time learning about them, now you understand the essentials. The value of these gems isn't only in what you see, it's in everything they've been through to exist. Jade and opal might look like ordinary rocks, but to those who understand the science and the market, they are true treasures shaped by the earth over millions of years. Now imagine you're walking along a river and you come across a stone like the ones we showed today. Green, heavy, dull, or maybe pale, with tiny, colorful spots on the surface. What would you do? Would you toss it back into the water or keep it to take a closer look? That's exactly where the difference begins, between those who let a gem slip away and those who recognize they might be holding something truly valuable. Learning to identify is the first step. Jade and opal are perfect examples of how appearances can be deceiving. Simple-looking stones that hide within them a structure shaped by millions of years of pressure, heat, and time. But the truth is, many of these discoveries are lost because the people who find them don't realize what they're holding. And that's when opportunists appear. People who know the real value of these stones and take advantage of the finder's lack of knowledge. They offer a few dollars for something that could be worth hundreds or even thousands once analyzed and polished. That's why, before selling or discarding any stone, the most important thing is to learn how to identify it correctly. Observe the texture, shine, weight, density, and the type of rock it came from. These are simple clues that make all the difference, and anyone can learn them as long as they know where to start. And that's exactly why we created the Gemology journey for beginners. The channel's Gemology book, available on Amazon. It was written especially for beginners who want to understand, in a clear and practical way, how to recognize a real gemstone hidden among ordinary rocks. Inside, you'll learn how to test hardness, shine, and translucence, identify indicator minerals, and understand how nature creates the stones the whole world values. So next time someone tries to tell you that what you found isn't worth anything, you'll know exactly how to respond, with knowledge, confidence, and certainty. And before we finish, remember this: never underestimate what the earth can hide. Every rock beneath your feet could be a page in the planet's geological history, and sometimes a fortune disguised as a common stone. In the next video, you'll discover another type of stone that most people ignore, but that might surprise anyone once it's cut open. YouTube will show you which one, and if you've made it this far, it means you're already part of the few who truly want to understand what they're seeing. Thanks for liking and subscribing. Good luck, Gem Hunter.